So good evening all, I'm Pramod Gaval, stay of this course. I'm going to take a problem solving session 9 on chemical reaction engineering 1, week 9, temperature and pressure effect on chemical reaction. The course tutor is Professor Vishwada Mandals, Chemical Engineering Department, IIT Guwahati. I hope so you have gone through the week 9 lectures which are available on same portals. So based on that, I'm going to take some problems. It may be MCQ and numerical. So starting from the MCQ one, the question one is the Lee Chatelier principle state that option given no reaction is reversible. B, all the reaction are reversible at high temperatures. C, a system experiencing disturbance shifts direction of the equilibrium to nullify the change. And D, a system experiencing disturbance does not shift direction of the equilibrium to nullify the change. So for the reversible reaction, any disturbance in the form of variation in temperature, pressure, and concentration affect the equilibrium states. The equilibrium shift in the direction such that if it is counteracted. So option C is correct. Question 2. For the reaction reversible, argues which of the following is correct expression of the CR? It is super. The final concentration of R in CR equal to CR naught plus CA naught XA. Right. So here this term CA naught and XA is the amount of A is converted to the R, which is the amount of R found. Right. Take the option D is. Question number 3. Equilibrium is a state in which option given rate of forward reaction greater than rate of backward reaction. Then rate of forward reaction equal to the rate of backward reaction. Then third, rate of forward reaction less than rate of backward reaction. And this rate of forward reaction is independent of the rate of backward reaction. So at equilibrium, the net rate of reaction is zero. The rate of change of concentration of A is zero, means equal. The rate of forward reaction and the rate of backward is equal. Question number 4. The equilibrium constant of reaction is 600. If the volume of reaction phase is triple, the equilibrium constant will be. So here is equilibrium constant given 600. And if here mention that volume of reaction class is triple at equilibrium constant. Okay. So if volume of reaction is triple, so what will the equilibrium constant? Right. So as you know, equilibrium constant does not affect the change in the concentration and volume. The equilibrium constant depend on the nature of the reactants, products, the temperature and pressure, particularly in the reaction involving gases. So it is independent of the concentration, therefore it is also the independent of the volume. Hence the equilibrium constant will be the same, means 600, even if we triple the value of the flask. Option B. Now question 5, conversion increase with increasing temperature in case of an reaction. So here Conversion increase in increased temperature means reversible endothermic. Question 7. Equilibrium concentration of material and equilibrium constant can be influenced by. This is the temperature. So option given means equilibrium concentration of material and equilibrium constant can be influenced by. So always remember the equilibrium constant is not affected by the any change in concentration, pressures, catalysis, inner gas addition in, but equilibrium constant is only affected by the temperatures. But here it is mentioned equilibrium concentration. So options CP correct. Kinetic of the reaction. Now question number 8. The following liquid phase elementary, the reversible reaction is taking place in a perfectly mixed flow reactor. So phi U gives R and R gives IU, where K1 is a reaction rate constant for a forward reaction and K2 is a reaction rate constant for a backward reaction. If K1 is a 36 meter cube per mole per time and K2 is 48 meter cube per mole per time, then find out the following. So here K1 and K2 given. So you have to calculate equilibrium constant and then fractional equilibrium convergence. So as you know, the equilibrium K forward divided by K backward. Right. So here K1 once denote the forward reactions and next to denote the backward reactions. So your value given, put this equation 36 by 48, right? 0.75. Right. This is the equilibrium constant. Now the part, the fractional equilibrium conversion of A will be. So equilibrium conversion can be find out by K EQ means equilibrium X EQ 1 minus X EQ, right? So, so here we have to find out equilibrium conversion. So make it this equation the equilibrium conversion. Okay, right. So we know the value of K equilibrium constants. So put in these equations 0.75 divided by 0.75 plus 1 equal to. Allah पे calculate and tell the answer. 0.42 42 42.85%, right? So we calculate the equilibrium constants. 0.75 and fractional equilibrium conversion of A will be 42.85%. Right. Moving to the question number 9, when 15 mole of 15 mole of PCl5 gas is heated in a 10-liter container and allowed to reach equilibrium at a certain temperature. It is found that 91% PCl5 is converted and 2.5 mole of Cl2 gas is present in a container. The reaction is. So here equation given, PCl5 use PCl3 and Cl2. It's a reversible. So this is like equation 1. So you have to calculate the equivalent concentration of PCl5 in mole per liter. Then equivalent reaction rate constant. This is equation 1. So you can write down simple A. So in A, right? Here initial PCl to 5 given 15 moles and conversion given, right? This is the final moles of Cl2. So in equal to 15 1 minus 0.91. So Na equal to 1 point. So the PCl5 products. Now this is initial mole final A B. So initial 15 and 0. So final A is 1.35 is the 2.5 moles. So here is a 7.5 7.5. Dichromatic ratio 1:1. Right. Now to calculate the concentrations, the moles divided by value, right? So PCl5 became equal to 1.35 divided by volume 10 liter, uh, 0.135 more per liter. 135 per liter. Now coming to the B part, equilibrium reaction rate constant. Now PCl3 to 7.5 divided by 10, so 0.75 mole per liter. Similarly, Cl2 equilibrium, so 7.5 to 0.75. Now to calculate the equilibrium reaction rate constant equal to concentration of PCl3 into concentration of Cl2 divided by concentration of PCl5. So put all the value in this equation. 0.75 into 0.75 divided by 0.135, right? So K equivalent 0.75 into divided by 0.135. Divided by 0.135. So 4.16 mole per liter. So thank you all. I covered all the questions based on the online chapters. So we will meet on the next Friday on next chapters. Thank you.